Okay, because it's farther away from the sun because of the tilt of Mars, which is similar to tilt of Earth, blah, 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 whatever. In the summer, the carbon dioxide will sublime. That's what carbon dioxide does, just suddenly sublimes, you know? That is, it goes directly from the frozen to the gaseous state, but there is still a residual polar cap. The residual summer polar cap is probably frozen water, which sublimes at T equals around 190 Kelvin. Pretty cold. Pretty cold. I hope you like the cold. Bring a jacket to Mars when you go there. At Martian air pressure. So basically, with the Martian air pressure, that's also going to play a role in your phase transition and all that, right? The frozen water will sublime at 190 kelvins. And although at present, yes, I think that life did exist on Mars, even if it was microscopic. It's very well possible because there is evidence of liquid water erosion on Mars. Okay, so if anything has liquid water, traces of liquid water erosion, I would, venture to guess that there might have been life there, but I don't know. That's a research topic that JPL, Jet Propulsion Lab. By the way, if you're interested in these types of topics, especially something like the Mars rover, Mars Europa, these are huge topics of research at the Jet Propulsion Lab, which is affiliated with Caltech. So if you want to study there, work there, whatever, then be my guest. Okay, NASA JPL, NASA Jet Propulsion Lab. Okay, I mean, that's just one example where this is studied. I mean, I'm sure it's studied elsewhere as well, but I know that Europa in particular is a big topic there. Okay, so at present, the water on Mars is primarily in its frozen state. So like I was saying earlier in the live that died, is that Mars, the water is frozen on Mars because it's too cold there. You know what I mean? It's kind of cold. In fact, I'm getting kind of cold now. I want a sweater. Just thinking about it. Just thinking about it, I would want a sweater now. Okay. Although at present the water on Mars is primarily in its frozen state in polar caps, clouds, or permafrost below the planet's surface. So there's frozen water in the Mars environment, like in its clouds and the polar caps below the planet's surface, but it's too cold, so it's frozen water. There is evidence that liquid water existed more abundantly on Mars in the past. The most obvious form of evidence consists of features on the surface of Mars that have been cut by running water. This is the liquid water erosion that I've been mentioning. Some narrow, dry riverbeds are found on Mars, meandering across the surface of the planet like rivers on Earth. The dried up Martian riverbeds are approximately 3 billion years old. 3 billion, judging from the density of impact craters atop them. In addition to the narrow, relatively orderly riverbeds, there are also broad flash flood channels found on Mars, the result of catastrophic floods rushing across the surface. The outflow channels can be hundreds of kilometers wide and contain teardrop islands. There's even some teardrop islands. Ooh, we'll show you these teardrop islands. I have a picture of them right here. Thus, liquid water existed abundantly on Mars in the past, although it does not at present. This indicates that Mars may once have had a thicker atmosphere and a higher temperature in the past than it does now. So if it had a thicker atmosphere, it could have been warmer there, and that would have allowed the liquid water to exist. Mars has two small irregular satellites called Phobos and Deimos. Fear and panic. God of war and all that, Phobos and Deimos are both heavily pitted with craters, just like our moon has craters too, because these are older surfaces. Moons are sometimes, our moon, I'm not saying every moon, but some moons can be pretty geologically